So looking at things on the Cartesian coordinate planes, one of the things I should be able to do is figure out how far points are from each other on the plane. Sometimes that's as simple as just counting. So for example, if I have this point and this point, I know that the distance between those is the difference in their y values since they both have the same x value of 2. And you can see here y is 4 and y goes down to 2 and 4 minus 2 is 2. So the distance between these two points is 2 units. Same thing is true if the points are horizontal. It, it's fairly simple to just look at how much their x values change. So here both of them have y values that are equal to 1. And you can see that my x value goes it's from 6, 7, 8, 9, 10. 10 minus 6 is 4. And yeah, the distance between those 2 points is 4 units. That's great, and that's actually quite useful observation. That's helpful when we have points that are not vertical or horizontal from each other. So let's consider these 2 points, and I'm intentionally making them not horizontal or not vertical, and I want to figure out the distance between these 2 points. How far, I can call this point A, how far is point A from point B? In order to answer that question, I need to observe a right triangle. And this right triangle is what allows me to calculate the length of the distance between those two. And the right triangle is always going to be formed by sketching 2 legs. The first one I can sketch, I'll just call that leg 1. And in fact, I'll write leg 1. And the second one I sketch, I'll just call leg 2. Leg number 2. These are at right angles to each other because the vertical and horizontal lines on our Cartesian coordinate plane are indeed perpendicular to each other, so this is a right triangle. Leg 1 has a length of 5 units. I can see that just by counting, right? It's 1, 2, 3, 4, 5. Or I could take 6 minus 1 and I get the 5. Leg 2 has x values that range from 3 to 6. 6 minus 3 is 3, so leg 2 is 3. So the length of the distance between these, right, ends up being the length of this hypotenuse of this right triangle. So the length of any hypotenuse is going to be the square root of, I'll just write this as leg 1 squared plus leg 2 squared. So what are the lengths of your legs? Square them, add them together, and then take the square root of that. So my first leg was 25, the second leg was 3. If I square, I'm sorry, my first leg was 5, the second one was 3. If I square 5, I get 25. If I square 3, I get 9. So the length of this segment is the square root of 25 plus 9. If I add those two numbers together, I believe I get 34. And then I'm looking at the square root of 34. Now, there's a couple things you can do. If you're asked to write your answer in simplified radical form, we want to divide out any perfect squares and break that up. But in this case, I'm just going to go ahead and write this by just giving it the answer to the nearest decimal place. So I'm just going to go the square root of 34 on my calculator, and I get 5.8. So the distance between those is approximately 5.8 units. One leg was 5, one was 3. The length of the segment that connects those points A and B is about 5.8, a little more than 5.8 units.